Hello, so in this video I will be demonstrating me creating an all NAND gated circuit using this equation. So my equation is Q equals parentheses complementing complement of A and standard B, that being ORed with parentheses A or complement of B and C. So here is the unsimplified standard circuit. Of course, it's before I turn it into its all NAND alternative. So here in this first AND gate, I have a complement of A. A passes through the NOT gate complementing it. That is ORed with a standard B. And these two terms that are ANDed together are all complemented by this NOT gate on the outside. And that is sent off to this OR gate. And my next AND gate includes a B, which is branched off, complementing it through this NOT gate, and is being ANDed with a standard C. These two terms are brought up into this OR gate, in which they are ORed with this standard A that I branched off earlier. And this term here is ORed with the complemented parentheses, giving me the equation. So from here, what I just did is I took the circuit and I brought it down and substituted all the standard gates for its all NAND alternative. So as we can see here, I kept all old complements and added new ones. So the standard AND gates include a little bubble. This little bubble means the entire term gets complemented, and it also includes a NOT gate after it. So as you can see, I included that bubble, its NOT gate, and I kept the NOT gate from above as well. And I copied that down for this other AND gate. It gives a bubble, and it gets a NOT gate, NOT gate. And up here, you can see the OR gates turns into an AND gate with a bubble, but it includes NOT gates, two NOT gates for each term that is brought up into that now AND gate, previously an OR gate. Same thing happens up here with this other OR gate. The OR gate that ORed the two final terms gets a little bubble in front and two knots in the back. So it's time consuming if you don't simplify from here, because let me just show you, it takes a while to kind of derive your final equation from said circuit, because it includes a lot of complementing. You get really confused. I'm pretty sure as I walk you through me doing this, I'm going to get confused and mess up myself. I mean. So I have complement of A being ANDed with B, parentheses, to not, this little bubble, include two more knots right here, 1, 2, alongside that, and then I'll bring this equation down over here. So I have complement of A and B with 3 knots on the outside, knotted again, and because of this bubble, it gets put into parentheses with a knot on the outside. And then from here, you will simplify. So when canceling out, you just cancel out doubles. So cancel, cancel, and you will get complement of A and B complemented. And simplifying from here, if you distribute that complement, you get standard A ANDed with complement of B. Okay, so that one wasn't so bad, but moving on to the next term, it gets a little more, I dislike it. It took me a long time to get through it as I practiced. So complement of B and standard C are knotted with a bubble in parentheses, bring down another knot complement right here alongside that, and I move on over here. So I can't forget I have an A that is complemented. So that complement of A gets multiplied with the term here. That's what's that term. So I have complement of B and C complemented or knotted twice. And then I need to add another knot to this term, only this term because it's in the same branch. But both terms here are knotted with that bubble complement. So add another set of parentheses. Let me rewrite that. Looks kind of ugh. And it gets, I don't have time to worry about perfection. Come on, Caitlin. It gets knotted or complemented. So I'll bring this term up here to complement it twice more. So parentheses, complement of A, multiplied with complement of B and C, 1, 2, 3 complements, parentheses, complement, adding another complement alongside that, complement because of this NOT gate, and then it passes through this bubble, adds another set of parentheses, and you complement that. Okay, and then here you can cancel out the complements. So here I will cancel these two, and I will rewrite it. So here I have complement of A multiplied with complement of B and C, and B and C has a complement assigned to that term, but all terms are complemented here. And from here, I can simplify. So this complement distributes, giving me standard A, and it cancels out here, A multiplied with complement of B and C. And let me just add some parentheses. Here we are. So Q equals A and complement B, and did with A multiplied with complement of B and C. There we are. If I got that correct, and that is my final term. And you can see that took me a while to walk through. So that's why instead of going through all that, you can simplify even further. So imagine all the pink isn't here. You will go ahead, and when you get this all NAND gate circuit worked out, you go ahead and you cancel out double knots. So here I have triple knots. I can cancel two. It doesn't matter which two. I can cancel these two, or I can cancel this one here and that one there. But because I want it to look nice, I'm going to cancel these two. Going down here, I only see that C has double knots, so I'll cancel these two. Okay, you don't cancel the bubbles, you leave those alone. So going down here is my simplified all NAND gate after canceling these NOT gates up here. So from here, it makes it much more simple to get your final equation. So let me just work through that real quick for you. I have complement of A and B, set of parentheses, and add the bubble complement. Bring that term down over here. So complement of A and B complemented with the bubble and complemented again with the NOT gate, set of parentheses, complements this term because of the bubble. And you can simplify that as well. So we are lucky I only have one set to cancel out. So just to show my work thoroughly, that is the simplified term, halfway simplified, because now I can distribute this complement. This cancels out, but it gets added to the B term, or B variable. So you get standard A and it with complement of B. Okay, so going down here, I have complement of B and it with C, and add this complement because of the bubble. Bring this term over here. Don't forget the complement of A, which is brought down from up here. That is ANDed with parentheses, complement of B and C complemented, and then you bubble this up, or you add another parentheses because of the complement bubble. Bring this term up over here to be complemented twice more. So complement of A, complement of B and C, complement, add another complement for the NOT gates, and then another set of parentheses with a complement for the bubble. And from here, you can simplify. So cancel these two. Show my work. So I have complement of A multiplied with complement of B and C with the complement, the final set. And here it simplifies beautifully. So distributing the complement, you get standard A multiplied with complement of B and C. So Q equals A and complement of B multiplied or ANDed with complement of standard A, I apologize, ANDed with the term complement of B and C. And as you can see, it is the same equation, but which one was quicker? If you have time to cancel out your NOT gates, you can get a beautifully easy way to get your final equation. And there we are.